Okay, this video is going to be an example of binary number conversion. We're going to create an HTML page, and on that page we're going to take some user input, a binary string, and then we're going to convert that into decimal, and then we're going to convert that to hexadecimal. So this is going to serve to reinforce how to convert between the different number systems, base 2, which is binary, base 10, which is decimal, and base 16, which is hexadecimal. Okay, and then it's also going to get us used to getting input data from an input HTML element, and then outputting that data to another HTML element. Okay, so this is going to be common throughout the rest of the course, where we create our website, we get input data from an element, we do something interesting with it, and then output that data to another element somehow. Okay. So let's get started. I'm in my dev folder. We've got a new file. We're going to call it, let's see, binary conversion.html. Okay, this is an empty file. Let's make a title. We get the basic generic document structure. Okay, this is an HTML document. It's the basic document structure, not an element. All right, the title we'll say is binary conversion. Okay, and in the body we'll have a h1 tag with the same title, binary conversion. Okay, so we save this file and double click on it and it should open up in our browser. Okay. Binary conversion. Alright, so first things first, we're going to make a span element that says enter a binary number up to 8 digits. Okay, then we're going to have an input, a text input. So this is an input HTML element. The type is text because we're collecting text data, and the initial value we'll set to 0. Alright, save it and see what we've got. Enter binary number up to 8 digits. Okay, that looks good. Add a colon and a space. Add a BR tag. We're going to add a button. That converts to decimal. We're going to have a button that converts to hexadecimal. And a BR tag here. I like to close mine. You don't have to. Okay, and then we're going to need an output. ID equals output. Now this ID has to be unique. Remember, that's very important. If you put an ID on something, an ID attribute on any HTML element, it has to be unique. Alright, so we also need an ID on our input so we can grab it. ID equals input. Okay. Okay, so we've got, you can type a bunch of stuff in here. Alright, that's working. Okay, so to make this easier, and because we don't have necessarily all the tools in our JavaScript tool belt yet, we're just going to make this a maximum of 8 digits. Alright, so there's a property, an attribute rather, that you can add to an input element called MaxLength, and you can limit the number of characters that the input will allow you to type. Okay, MaxLength is the name of the attribute. You're setting it equal to a value surrounded in strings, or in quotation marks, making it a string, and the number 8 is inside. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I'm still pressing, and it does not allow me to go past 8. Okay, so that's going to be useful for us. So we know we're going to have a string that's between 0 and 8 digits. Alright, let's make our JavaScript tag. Alright, so this first button is going to have an on-click attribute that's going to call a function. That function we'll call convert to decimal. Left and right parentheses to call the function. The second button is going to have an on-click attribute that's going to call the function convert to hexadecimal. Left and right parentheses to call the function. Okay, so right now we'll get errors because we have not defined those functions. Okay, we open our developer tools. In the console, when we click these buttons, we should get errors. Convert to decimal not found is not defined. Convert to hexadecimal is not defined. Okay, so let's define those. Use the function keyword, convert to decimal. Convert to decimal clicked. Alright, copy that function, and we want convert to hexadecimal. Okay, so these functions should exist now. Refresh the page, click convert to decimal clicked, convert to hexadecimal clicked. Alright, we're in good shape so far. Alright, convert to decimal. Let's start by getting the data, the input data. Okay, so we put an ID on our input element. This ID can be anything, any string. We called it input. There are limitations on the characters you can use, but for all practical purposes, you can type in whatever you want here. And so we go variable input element, input el, document.get element by ID, and this is input. Console log input L. Okay, let's see what we got. There it is. So that's working correctly. Alright, now we need to get the value, the user data that has been typed in that input element. So we've done that several times. Input text is what we'll call the variable. Again, you can call the variable whatever you want. So we're going to take the input element and call the .value property. This is going to store in the variable input text whatever the user has typed in here. Console.log input text. Alright, reload the page, type in some stuff. There's our input text. Okay, pretty standard, we've done this plenty of times. Now we want to make sure we have the right type of data. Okay, so we know it's at least 8 characters, but it could be less. So in order to do this binary conversion, let's pad the left of the string. If it's less than 8 characters, we'll pad the left side with zeros. Okay, because in decimal 0, 0, 0, 1, 2, 3, 4 is the same as 1, 2, 3, 4. The zeros on the left don't mean anything. You can drop them or you can have them. Okay, so in binary it's the same thing. We'll pad the left of the string of ones of zeros with extra zeros. That way we're sure we have at least 8 digits. Okay, so var, we'll call it padded equals input text. Okay, and so built into all strings is a function called pad left. Okay, so since this variable contains a string, we can access this function on that string. We could have a string literal in here too, dot pad left, if we wanted. Okay, so input text pad left. The first argument is the number of characters that you want to pad. Okay, so the total number. So if you have a string that's less than this number, it won't pad any. So pad left 8, and the character we want to use to pad is 0. Okay, so let's take a look at that in Node real quick. We'll play around with this pad left a bit. Okay, so we have a variable string equals 101. Okay, if I type str.pad left 8 characters and add zeros to the padding. Oh, pad left. What's it called? Oh, pad start. My bad. Pad start. So we have str.pad start. We're going to pad up to 8 characters. If it's more than 8 characters, we won't add any padding. If it's less than 8 characters, we're going to add padding at the start of the string, and the character we're going to use to pad is the character 0. Okay, so you see we started with the string 101, that's 3 characters, so we've added 5 zeros. Okay, so this is good for numbering things too. Let's say we were making a list to display some console.logs, and we had a numeric list, and you go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then when you get to 10, there's an extra digit here. Right? So if you want everything to line up, if you wanted all these parentheses to line up, you'd want to pad each one of those with a space, so all of our parentheses would line up in the output. Okay? So if you had 100 items, 99, 100, and you want all the parentheses to line up, you'd have to pad all of those and all of these by 2. Okay? So it's useful for formatting and numeric lists, or something like this where we want to make sure we have zeros padded on our binary number. Okay, so again, that's pad start. There's also a function pad end. So if I have 101, I can do pad end. I have 8. I want to pad up to 8 characters. If it's less than 8 characters, that's when we add padding, and we're going to add a 0. So this time it padded the end of the string with zeros. Okay, but for our purposes, we want pad start. Okay, but for the counting one, let's say we had a number equals, let's say it's number 17, and we're going to console.log a whole bunch of things, and we knew we had over 100 items, so we're going to do num.pad start. We're going to make sure there's at least 3 characters before our parentheses. 3 characters, and then the padding character is just a space. Okay, you see it adds a space before the 17. And if instead of 17 we had 9, it would add 2 spaces. Okay, if we add in our parenthesis, change pad start to 4 because there's an extra character. Let's see, 17. These parentheses line up. That sort of thing. Okay, so that's pad start. Alright. So we've got this string and we've padded it. With zeros to the left, up to 8 characters. Because we added max length of 8, there should be no way it's greater. The length of the string is greater than 8. Okay. So let's take a look at this. Convert to decimal. There it goes. It padded all the characters. Okay, so now we need to validate and make sure we have good data. So if somebody types in 0, A, we've got bad data here. That's not a binary number. Okay, so so at this point we know we have a string with at least 8 characters because pad start ensures that. Pad start, we're saying if there's fewer than 8 characters, add zeros. So we definitely have a string with at least 8 characters. So we can reference these items, these individual characters, by index. Let's log these real quick. Console.log. Padded 0. That should be the first character in our string. One, two, three, 4, 5, 6, 7. Okay, that's all 8 characters. convert to decimal, 8 zeros. Okay. There was no padding because I used all 8 characters here. But these are the individual characters. To reference the content of a string, the individual characters, you use square brackets and then the index number. The indexing starts at 0 in increments 1 at a time. So the nth item, this is the 8th item, you access it with the index n minus 1. This is the 8th item, so 8 minus 1 is 7. The first item, if n is 1, n minus 1 is 1 minus 1, which is 0. Okay? So we went over that previously in this lecture series. So what we want to say is if padded, if the first character is does not equal a 0 and padding 0, the first character does not equal a 1, console.log bad data. You must type all zeros or ones. Okay, so this is just going to do the very first character in the string. So it's just going to do that one. Do that to start out with. And then we return. If we get bad data, we return. Alright, so let's reload, convert to decimal, and let's do, okay, padding is not defined, oops, padded is what we want, padded. Alright, well, I just can't type. Console. There we go. Okay, bad data. You must type all zeros or ones. So that only handles the case for the first character. If I go convert to decimal, this is fine. So far it likes it because it starts with a 0 after we pad it with zeros. Okay, so basically for every single one of these characters I have to check and make sure that it's either a 0 or a 1. That needs to be the string one. Okay, reload. We can test it with 1. Okay, that one's fine. If it starts with a 0 or a 1, that one's fine. If it starts with a 2, for example, bad data. If it starts with an A, bad data. If it starts with a space, bad data. Okay, so right now we're just testing the first character, so we want to test all of the characters. Okay, so we could duplicate this and go the exact same thing and look at the second character and copy that and look at the third character. Okay, but it's kind of a waste because we're duplicating all of this code over and over and over. So let's go ahead and do it real quick. You see how much more code there is. 3, 4, 5, 6, 7. Okay. 3, that should be 2, it's not equal. Oh, I did the wrong thing there. Okay. Copy and paste mistakes. Alright. So we got padded 3, we need padded 4, 5, 6, 7. Go back up here. Padded 3, padded 4, 5, 6, 7. And we'll go ahead and add a number that tells us what character it was, or what index. Okay, so this is not, we're duplicating a whole lot of code here. In general, in computer science, if you're doing things 2 or 3 times, you need to abstract that and reuse your code. Write a function that reuses the bulk of the code. Okay, but this is an example of how big this gets. It's a huge block of code. And we're doing something pretty simple. We're just going through each one of 8 items and logging bad data. So, oops. If we reload this page, we should see that this works out fine. If we have any bad data, it tells us which character is bad. This was the 6th, and went all the way through here and got to the 6th character, or the 6th index, which is the 7th character, and found a 2, which is bad data. Okay, here the 7th character, or the 8th character, is bad data. Okay, so rather than do this, we can make this a little bit cleaner by making use of a complicated Boolean expression. So what we're going to say, this Boolean expression, if the first character does not equal 0 and the first character does not equal 1, it's bad data. But there is another option. So if the first character does not equal 0 and the first character does not equal 1, or the second character does not equal 0 and the second character does not equal 1. Okay, so this is a complicated Boolean expression. What we have here is, this is the first character, referencing by index of the string padded, the string stored in the variable padded. If that does not equal 0, so let's say, for example, we have the string A, a bunch of A's. Or we'll do A, B, C, D, E, F, G. Okay. So this would evaluate to the character A. A does not equal 0. So this is true. And A does not equal 1. So that's true. The AND statement is true when both things are true. Okay, so this whole statement becomes true. We're going to have a bunch of statements separated by ORs. So remember, the OR operator is true if any operand is true. So if any one of these lines, the entirety of this expression, if any of those are true, we know we have bad data. And so we'll say bad data. Okay? We know this particular line is true if the first character isn't a 0 and it isn't a 1. Anything else is bad data. Okay? So the two pipes here are using is the Boolean operator OR. So again, each line here, this represents the first character. We're checking to see if it's a 0 or a 1. If it is, fine, move on to the second one. Is the second character a 0 or a 1? If it is, fine. And we go all the way down the list. If at any point any of these become true, then we're going to go into this if statement and say bad data. Okay, so this is still kind of a lot of code, and there is definitely better ways of doing this, but we don't have all the tools yet. However, if you compare this size here, that's 32 to 45, right? So that's 10, 11, 12, 13, 14 lines of code versus, if we go back here, we have from 31 to 62. So we like roughly halved the lines of code. Alright, basically this just gives us, make sure we have good data we're working with. Alright, so now at this point we have valid data. Okay, so we're going to convert this string, and this is still string data, console.log type of padded. Expected token 41. Oh, there we go. I had an extra OR statement. This is the last Boolean expression, so I don't want the final OR statement. Bad data. Bad data. Let's try all ones. That's fine. All zeros. That's fine. Okay, and keep in mind the type here is string still. Okay, so now we're going to go through and convert this number to decimal. Okay, first we need to remember how the powers, how the number system works. When you go from right to left, the digits place goes up by powers of 10. So the unit digit in decimal is 10 to the first power. Okay. The tens place is 10 to the first power. That basically tells you how many tens you have. I'm sorry, the first one is 10 to the 0, which is 1. Second place is 10 to the first, which is 10. The third place is 10 to the third, which is 100. Okay, so when I have the number 347, this place is the number of 100s I have, which is the number of 10 to the thirds that I have. 10 to the seconds, I'm sorry, I'm messing this up. There we go. Alright, the 4 is the number of tens we have. And that is the number of 10 to the firsts we have. The third number is 7. That's the number of ones we have. Okay, and that is 10 to the 0 power. So as you go from digits, if we had an 8-digit number in decimal, 2, 3, 4, 5, 6, 7, 8. Okay, we normally add some commas so we can see, but that's 99,999,999. Okay, what that's saying is 10 to the 7th power times that digit value. How many do we have? We have 9. So it's 10 to the 7th power times 9. Let's make this 9, 8, 7, 6, 5, 4, 3. Let's pad it with a 0. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. 8 digits. Okay, so this first one is 10 to the 7th power times whatever digit we have here, plus 10 to the 6th power times whatever digit we have there. Let's go ahead and group these. So the digit we have there is 9 plus 10 to the 5th power times our digit, which is 8. Okay, so let's go ahead and clean this up a little bit. Plus, we got 10 to the 4th times our digit, which is 7. 10 to the 3rd times our digit, which is 6, plus 10 to the 2nd times our digit, which is 5. Now 10 to the 2nd, remember, is the 100ths place. 10 times 10, that's 100. That's our 100ths place. There's 5 of those. That's why we're multiplying by 5. Now we're in the tens place. 10 to the 1st power times our digit, which is 4. So we have 4 tens, and that's 10 to the 0 power times our digit, which is 3. We have 3 ones. Okay, so this is base 10. So we can do the same thing for an 8-digit binary number. We got 1100, 1010. Okay, so we can copy this, paste it. But our base has changed. We're no longer in base 10, so all of these are 2s. Okay, our digits changed. We have a 1 starting on the left. This is 2 to the 7th, so this is the highest digit. It's a 1. Then we have a 1, a 0, a 0, a 1, a 0, a 1, and a 0. Okay? If we want to convert that to the actual value in decimal, 2 to the 0 is 1, 2 to the 1st is 2, 2 to the 2nd is 2 times 2, which is 4, 2 to the 3rd is 2 times 2 times 2, which is 8, 2 to the 4th is 16. So basically with binary you see that it's just doubling each time. So this is 32. And this is 64, and this is 128. So since we know this, we can go one digit at a time in our string here, and we know which digit is which. We know that we have 8 of them, and we know that they're always a 0 or a 1. So on the first digit, if it's a 0, then we would multiply this 128, because this is the 128th place. We'd multiply it by 0 and add it to our running total. Then we go to the next digit. Alright, if it's a 0, we multiply by 0. If it's a 1, we multiply by 1. Okay, so that's the logic going through here of how we're going to do this. Okay, so I'm going to comment that out. I'm just going to delete it. Okay. So we're going to have a running total. We're going to add all these things up. So we create a variable called sum and set it equal to 0. Sum equals we're going to start with, let's see, if padded 0, if the first digit equals a 1, which it's string data, so it's going to be a string. If that equals a 1, then we add to our sum. Sum equals whatever it equaled before plus 128 times 1. Okay, if it equals 0, then we add 128 times 0, which is nothing. So we can just go ahead and not write any code for that, because we won't be adding anything. Okay, so if the second number is a 1, then we're going to add to our sum 64 times 1. The third number is the 32's place. If it's a 1, we're going to add a 32. The fourth number is the 16th place. If it's a 1, we add 16. Oops. 5. So the 5th index number, which is actually the 6th number, is the 8th place. If it's a 1, we add an 8. The 6th index number is the 4th place. I skipped 2. There we go. 2, 3, 4, 5. There we go. If that's a 1, we add 4. The 6th index place is the 7th number in the string. That one. If it's a 1, then we're going to add 2, because that's the 2's place. And the very last one, this is the 8th character in the string, has an index of 7. If that's a 1, then we just add a 1. And then let's display our sum. Okay, 0. So a 1 in binary is a 1 in decimal. A 10 in binary should be a 2. The sum is 2. 1, 1 in binary is 3. 1, 0, 0 should be 4. We have a 1 in the 4's place, 0 in the 2's place, and 0 in the 1's place. Okay, so if I go that number is 213. What's the highest number we can have with 8 digits in binary? Make them all ones. It's 255. Which makes sense because in decimal, if we have 3 characters, 3 digits, they're 9s. If you add one more character, you have to roll over into the next decimal place. Okay? So you would have one of those things. In this case, you would have 1/1000. If you add one more to this, these all turn to zeros and you add a 1 in the next place, which would be 2 to the 8th, which would be twice this, which is 256. Okay, we have 1 less than 256, which is 255. Okay, so now we need to grab our output element and output it to the screen. Our output element equals document.get element by ID output L dot inner text, and we're going to set that equal to the sum. $255. Bad data. $187. $13. Okay. Okay, so that's converting to decimal. Alright, so let's convert to hexadecimal. For this, we're going to cheat a little bit. Let's go ahead and copy this over. We got our input text and we got it padded. So we're going to do the same thing down here. We have our input element. We're grabbing that. We're grabbing the input text by input element.value. We're padding the input text with zeros. Okay, so now we have our string data. If we get this, we need to add this in here. Okay, so now we're duplicating a lot of stuff in here. Right? We've got this doubled basically. So what we need to do is abstract that out and make a helper function. We'll call function. We'll name this function get valid data. Alright, and basically we're going to take all of this, which at this point gives us padded, which is our valid data. We're going to return padded. And so now we can say, we can delete all this and say, oops, we'll leave that first one. Variable padded equals get valid data. And then down here, we can remove all this and say variable padded equals get valid data. Okay, that makes our code much smaller. So this is a helper function because we used it twice. The only reason I pulled it out into its own thing is because we used it twice. If we had a bunch of different buttons here, we're converting to a bunch of different bases, we might use this 10 different times. There's no reason to duplicate all of this code. Alright, so console.log padded. Okay, let's make sure everything's still working. Type undefined. Oh yeah, we need to return from this function if not padded. If padded doesn't exist, or we return undefined. So if padded equals undefined, we'll return out of our function. Bad data. Okay, let's do that one. Padded. Okay, so we're good there. So we know we have a string that's 8 characters long. Alright, so first, hexadecimal. If we go binary to hexadecimal, that one's easy. We chunk out the binary digits in blocks of 4. And every 4 binary characters relates to a single hexadecimal digit. Okay, we went over that in the number systems lecture. Okay, so let's make a conversion object. We're going to convert a binary block of 4 to hex character. Convert binary block to hex character. Block. So this block is going to be a chunk of 4 characters we're going to pass to it. Okay. So we can make an object that is block to hex, and if you give it the string 0000, that is the binary character 0. We'll do all 16 of them. Binary number 0001 is hex character 1. That's 2. That's 3. That's 4. That's 5. That's 6. That's 7. And that's 8. Okay, now you notice this first digit all has zeros. Now we're going to repeat the same pattern we have in the first 3 digits down here, but we'll have 1s in front of all these. So you'll see the pattern duplicates. We got 3 zeros here, 3 zeros here. 2 zeros and a 1 here, 2 zeros and a 1. Okay. One zero one. There we go. That's all of them. Okay, 7, 8, 9. 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F, which is the highest. So basically, whenever we get this block of 4 binary digits, we can pass it into this object and get the hexadecimal digit back. So we're going to return the value block to hex, pass it in the key value, which is block. It's going to be a string value, block. What this does, this is an object that we've created here. Sorry, this should be a function. We've created an object here, and these are the name. That's the name of the first property, and the value is string 0. This is the name of the second property, and the value is string 1. Okay, we could have done this with if statements. There's a number of different ways we could have done it. I chose to do it with an object. Alright, so if we return block to hex, we pass it in the 4 digits, and we should get one of these characters back. So if we do that with the 2 4-digit blocks, then we should be good. Okay, so what we do is we have our padded number, and we're going to say our 2 characters. We're going to have two hexadecimal characters. So our hex string is going to equal nothing to start with. Hex string is going to equal what it did before plus convert binary block to hexchar. We have to pass in the first 4 characters of the padded string. Okay, so that's padded 0, which is a string, it's a character, padded 1, padded 2, and padded 3. And then we're going to pass in the second block, 4, 5, 6, and 7. So we'll go log hex. Okay, let's see what we've got. That's string AA. Let's see if we got 1 1 1 1. That should be 0F. 0F. We do 1 0 0 0 0. That should be 116. So that should be 1 0 in hex. This is the 16's place. There's 116 there. So in hex that's 10. Okay, and the very last thing we do is, just like down here, we grab our output element and set the inner text. 10. So that's 116 and 0 ones. This is the 16's place in binary. We have 116, we have 0 8s, we have 0 8s, 0 4s, 0 2s, and 0 1s. So in hex we have 116 and 0 1s. If we do all ones, FF. Okay? Alright, so that's binary conversion. There is more efficient ways of doing all this, but this is a good way of doing it considering we're limited by the tools we know so far. But we went over several things like reducing code reuse, or not reducing code reuse, making sure we reuse code, which is important. Because all of this, we would use this twice, so that would have been increasing the size of our code block. Alright, and then this is also a refresher on number systems and converting from one to the other. Okay. The other thing we learned that was interesting was this max length property on an input value. And pad start on a string. Those are the major takeaways of this. Also, we have a complicated Boolean expression, so you get a sense of how complicated these can get. When you break it down, it's actually pretty simple. This is the first digit a 0 or a 1? Is the second digit a 0 or a 1? But you have to think through it logically, and that can be a little tricky, especially with as many sub-expressions are in here. Okay. So that's it for this demo. I'll post all of these. The HTML files I'll post in the public folder of my CS15100 account, and the other ones I'll post just in that account, not the public HTML folder. And I'll label them so you can access this stuff. So you might use some of this as a starting point on your homeworks and your labs. Okay, that's all I have.